Hello, everyone, and welcome to another exciting session of NextGen 23, the industry's largest drone autonomy summit. So, just before we begin, I would like to great. It would be great if you could let us know a little more about yourself, and so that we can get to know you better. So, if you could drop us some information on the chat section. So, where are you joining from, and what excited you most about this session, right? And so, with that, let's begin. So today in this session, we are discussing the very critical topic in the world of uncrewed aviation, the necessity of ADS-B and C2 network for beyond visual line of sight flights, right? So with that, we have our next speaker, and our next speaker is a veteran of the industry with our decade experience in avionics, C2 systems, DAA, propulsions, power distribution, and control. Please welcome Joe, the Director of Civil Uncrewed Aviation Sales at Avionics. So, with Avionics was founded with a mission to of bringing safety solutions to uncrewed aviation industry to aid in the integration of uncrewed aerial systems into our national airspace systems. As the Director of Civil Uncrewed Aviation Sales, Joe is responsible for helping uh, to bring these solutions to market and working with clients to integrate them into their operations, right? Joe has been working with uncrewed aviation industry since 2008 and seen firsthand the incredible growth and evolution of the technology. He brings a wealth of knowledge and expertise to our session today. We are thrilled to have him share his insight with us, right? But just Joe, let's just wait for a minute more. So, but before we begin, right, I pass it over to Joe. I would like to share some housekeeping rules with it. So please type your questions in Q&A tab in the during the session. It will be answered or taken during the and at the end of the presentation. The session is getting recorded, and all these sessions will be shared with you guys over the email, or you can visit our Flight NextGen website. And we also have a UAV avionics solutions booth in the expo section. Please make sure you visit it during the networking booth. And right, so finally, please remember to capture your favorite moments, right, with of the sessions and share it on Twitter, LinkedIn by using a hashtag NextGen23 and tagging Flightbase. And definitely do not miss out Joe Gibbs from Avionics, right? So there is ongoing poll during the sessions. Please participate. And lastly, I would like to thank you, our sponsors, the title sponsor, DJ Enterprise, and our platinum sponsor, Volatus Aerospace, for supporting this event and helping to make it possible. So with that, further ado, please give a warm welcome to Joe.
Yeah, thank you, Vinyak. Excellent. Thank you. Pleasure to be here. We have a lot of international clients at Avionics, so
right.
This is a very good opportunity for us. We're excited.
Let me just quickly share your presentation for that. Okay.
Thank you.
Okay, 1 second. But it's just juggling me out of that. Okay, guys. Yeah, we are almost there with that. Okay, Joe, can you say it?
Yeah, so title of the presentation, Extending the Reach, the necessity of ADS-B and C2 networks for BVLOS flights. BVLOS is beyond visual line of sight. It's often referred to as the holy grail of UAS operations. It supports things like inspection, linear inspection, autonomy, things like package delivery and urban aerial mobility, taxis of the sky, right? So go ahead, sir. So we're just going to talk about accelerating the safety case to get a BVLOS waiver. That's a process that the FAA, the Federal Aviation Administration in the United States, has developed for operations. And helps scale up an operation, especially for things like we just mentioned, autonomous flights, inspection, things like that. Go ahead, Vinay. UAvionics, we develop and manufacture very small components, avionics. Just as a background, Paul Beard is our CEO and has a long history of work within the radio control community, the hobby community. He was the CTO at Horizon Hobby and is actually the inventor of spread spectrum technology. This is a 2.4 gigahertz technology that the industry widely adapted. Basically, this prevents interference, so you can fly a drone or an airplane through RC without getting interference from other RC operators. So this is a standard that has been incorporated within the industry, and even in the drone industry, most folks use this type of technology. Paul also worked in telecommunications through British Telecom, developing voice and data terminals, and just brought a team of experts from telecom, from RF, and from semiconductor industries, and put it all together and created UAvionics. So we have a kind of a unique history, quite a few patents, just a wonderful portfolio of patented technology, and now we're building from the ground up a certified C2 system and a certified network manager we're going to talk about. Go ahead, sir. So we're developing a centralized network for command and control and detect and avoid. So command and control is a radio link that actually flies your drone. And we're most interested in making sure you don't lose your drone and you don't have a lost link scenario. This is what leads to accidents. This is what leads to drones crashing. If people in the audience have been around this industry for a long time, they know drones do crash. And so we're trying to prevent that. We're building a network with path diversity and redundancy. So we're using ISM radios, 900 megahertz, LTE radios, which is cell phone, satellite communications, and then C-band, which we'll talk about a little bit more, which is a dedicated aviation band, a worldwide dedicated aviation band for UAS that we're developing from the bottom up. And we're not taking a radio technology and adapting it for UAS. We're designing a radio technology to facilitate UAS from the ground up based on some performance metrics that have been published. Okay, next slide. So we're creating an ecosystem, and as we just described, we're using multiple paths to make sure your drone stays in the air and you have path diversity. C-band is a dedicated aviation band, so you might see a radio like this. This is one of our high-power C-band radios. They're small, they're lightweight, and they're made to be certified. We also have a SATCOM module, an LTE, which is the cell phone module, and an ISM module. But the reason we use multiple paths is because you can have either for instance, LTE can go down. For instance, last week, I used T-Mobile, which is a large operator, one of the big three in the United States, and our cell phone service went down for about 6 hours one day. No excuse, no reason why, it just went down. So you can imagine if you're relying on solely LTE with a UAV and you're flying beyond line of sight and the cell service goes down, your UAV is just going to keep going, and you're probably not going to get pick up your link again. In this case, we're using multiple bands and making sure you never lose the link. So we're providing the autopilot on the right, the link manager, which is the cloud-based manager we call Skyline. We're having we've developed a GPS unit, which is a integrity GPS and a certified GPS. So we're not So you can get GPS units for your phone, for instance, but they're not aviation grade. So what we've done is we've developed a GPS unit that's actually certified in aviation grade. And then, of course, ADS-B, which is automatic dependent surveillance broadcast, which will identify other aircraft in your area of operation and let your UAV, if needed, produce countermeasures to avoid piloted aircraft. Then this all feeds on the left side. You got your command and control data that goes down the pipe, your UTM, your unmanned traffic management system, and then your DAA, which also includes things like uncooperative aircraft and primary radar. Vignac, go ahead. So this is the this is how we develop mission assurance, right? We use ISM. This is a scientific band, 902 to 928 megahertz. This is primarily the radio band that most people in the United States, for instance, use when operating under Part 107. Now, Part 107 is a way to operate drones commercially in the United States. But there's a lot of regulations and a lot of limitations for what can be done. You have to fly under 400 feet. You have to have line of sight to your drone at all times, or a visual observer line of sight to your drone. So it really limits the type of operations you can do. Mostly inspection, like bridge inspection, construction, things like that. It can facilitate some research and development surveys, but not a lot. And it just limits to what you can do. Photogrammetry can be done within Part 107, but it really does limit what you can do. That's why the BVLOS process and the waiver process is said to be like the holy grail of UAS operations, opening up other applications like the package delivery in the UAM market. But we're also using LTE. LTE is very established. It's very reliable. We use it every day. It roams. It does everything we need to do. But as I mentioned earlier, LTE has some downfalls as well, especially in remote areas, mountainous areas, areas that just simply don't have coverage. So you can imagine you're flying your drone in your BVLOS mission, and all of a sudden you lose coverage for a while. That's called a lost link scenario, and you might get the link back after a bit, but in the meantime, the drone is flying by itself without a pilot. C-band is a dedicated aviation band that we're developing radios for. We have these radios. We've deployed probably 20 or 30 systems so far. We have some test sites that are using C-band. This is a dedicated aviation band. It's good all around the world. It's been reserved for aviation, and in some countries like Malaysia, for instance, they're starting to use it exclusively. And then, of course, SATCOM, we talked about that. If there's no other communication, SATCOM is often reliable. So having multiple paths means no lost links. Okay. So path diversity, of course, many links. All of them are communicating all at once, but only one is actually flying the drone. So we're monitoring every path. And what we do in Skyline, which is the cloud-based application, is we have what's called make before break. So we have a system where you're never losing link, even for a fraction of a second. So we'll have two systems. For example, say you have a radio system linked to your drone from the ground, and your Skyline application manager saying the signal is starting to get less reliable, less strength, and we're going to switch you over to LTE, for instance. Well, it won't drop that radio link until it has a good LTE link. Then when it has a good LTE link, it's basically got both links. It drops the radio links. It goes to LTE. Flies with LTE for a while, and then the same process happens again. If the LTE link is becoming problematic, but the radio frequency link looks good, it'll do the same thing and switch back to the radio link. So that makes, again, no loss link. That makes your safety case. That makes it easy to get approvals, whether it be the FAA or any other aviation authority that would grant you approvals for things like pipeline inspection, power line inspection, search and rescue, forest fire inspection, things like that. Okay, go to the next one, Vinkay. And path diversity is when the radio information has more than one physical path to the destination. And this is what we just talked about. More than one radio on board. So we may have an ISM radio, we might have a C-band radio, LTE, and they're all talking at once. Okay.
Should I go back?
Yeah, no, go to the next slide. That's good. All right. Yeah. Now this is frequency diversity, which is what we just briefly talked about. But this is where we're using different types of communication: SATCOM, LTE, radio waves, etc. So you have path diversity, multiple paths, and then multiple frequencies. So you're not just relying on multiple RF links or multiple cell phone links, right? So if you're saying, well, I'm just going to use all cell phone, for instance, all LTE, that's going to be problematic in a BVLOS situation, because great, you can swap and use different carriers and different towers, but when you're in a rural area and when you're in a mountainous region, a canyon or something like that, you might have no cell phone from any carriers, and then that could cause a lost link. So having a SATCOM link and an RF link as backups or primaries just eliminates that and makes the safety case for regulators. Go ahead to the next slide.
Okay.
So this is a visualization of Skyline. This is a web-based application. This is what manages the radios, the telemetry of your drone between the ground radios, the airborne radios, the LTE, the SATCOM. Then we have what's called an ADS-B receiver on your left. That's a dual band receiver that receives ADS-B signals from piloted aircraft. So that gives you visualization. This is a small graphic, but you can see aircraft in here. That'll show you aircraft. That'll show you their direction, and that'll allow other aircraft to see the drone, but just as important, it allows the drone to see other aircraft so it can make evasive maneuvers. So this is the detect and avoid, right? The ADS-B, you see the other aircraft, and then you can avoid it with your mission computer on board, or with your planning tool, or your remote pilot that may be on the ground. Then we've integrated primary radar. So, for instance, in North Dakota, the Mavanta system, and in Oklahoma, Choctaw Nation, we've integrated primary radar. So primary radar acts to detect uncooperative aircraft. So here in the USA, we've had an ADS-B mandate that mandated owners of light sport aircraft, something like a Cessna, a Piper, something like that, single engine aircraft that are very prevalent in the United States, for instance, are required to equip with ADS-B. That's been the mandate for the last couple of years. Pretty much the entire fleet is covered, but there's some outliers that might not have it. So you have an ADS-B receiver that'll get you 99% of the traffic, and then you have your primary radar for uncooperative aircraft. Or there's other systems like vision systems you can put on your UAV. But so we're doing two things. We're we're providing command and control, and we're providing situational awareness of other aircrafts to avoid collision. Go ahead to the next slide. So this is sort of important too, and this is something that if somebody, a user comes from the industry, the commercial industry, they understand what's called DAL levels. This is design assurance levels. This is something for like any kind of aircraft, whether it be cargo or passenger aircraft, they are certified. It does cost a lot of money to certify an aircraft, and it costs a lot of money to even make the components that are certified that go on a certified aircraft. So UAvionics, we make certified components that go on a drone. And what we did here is we have a GPS unit, which sort of looks like this, right? A small GPS puck, but this has an FAA certification or a TSO, technical standard order. So if you're taking your drone and you're doing a type certification process, it can be much cheaper and time consuming if you use certified componentry. So instead of using you could possibly get a type certification without a GPS unit that is not certified, but using a TSO avionics in a certified GPS unit, maybe a certified transponder, maybe a certified autopilot, maybe a certified radio control link, makes the process of obtaining a type certification much easier. So that's something we've looked at UAvionics, is how do we take this industry, the UAV industry, and go from where it was in 2008 using bespoke components, using hobby grade components, using components that didn't even belong on aircraft. For instance, I mean, there's aircraft out there, there's drones out there using lawnmower engines, right? There's drones out there using chainsaw engines and all kinds of different things. They're using hobby grade servos and things like that. How do we lift this industry and use aviation grade parts? So that's what we're doing. So we're doing DAL level C, which is a design assurance level C, which is very rigorous. We're doing DO 254 for the hardware. That would be the everything in the board, everything, the hardware is tested for all kinds of things: temperature, rain, salt, sand, all kinds of intrusions and whatnot. And then the software has to be certified. For instance, in the GPS unit that I showed you, there's software in here that makes this a certified unit, and that software has to be designed to that. So going back to the radios in the BVLOS system, there's a couple of MOPs. RTCA, that is the Radio Technical Commission on Aeronautics. They set guidelines and rules. So what they've done is they've got two rules. One is DO 362, which is a MOPS. That means minimum operating performance standard for the hardware. So what they've said is this hardware, this C-band radio, needs to conform to these MOPS, DO 362A. So when I said we build these, from the ground up, that's what's happening. It's taking what the RTCA has published in building the hardware to that. DO 377A is a MAS, that's the minimum aviation system performance standard. That is the ecosystem, which is the cloud-based ecosystem that manages the drones. And this is very important with package delivery and urban aerial mobility, meaning if you have multiple drones in the sky delivering packages, you have a system that operates those safely, that deconflicts those safely, and it also communicates with the ATC, air traffic control. So What's coming out is a TSO. It's Charlie 213A. That's coming out from the FAA, and we will certify our radios to that, and that'll be another certified building block for UAS. We're building these exclusively for UAS uncrewed aerial vehicles, and so that's the basis of where our company is in essence trying to lift the industry from where we are now to building aviation grade components, certified components, and then certified aircraft that can fly in any condition, in controlled airspace, near airports, where not. And so we're getting there. This industry has really evolved a lot since I started in 2008, but it still has a way to go. So we have our philosophy on how we want to help the industry move. Okay, go ahead, sir. So path diversity, multiple paths, frequency diversity, not just one type of system, like not just a radio frequency, not just LTE, but several different ones. And then ADS-B for sense and avoid, and then incorporating radar and different sensors like visual sensors and whatnot for the uncooperative aircraft. So we're making a cloud-based network manager we call Skyline. It's built to the DO 377A MASPs, so it's built to the standard that's put out there. Okay, next one. And then talking about waivers, this is kind of cool and interesting anyway. But this year, January, the FAA approved our first BVLOS waiver, and we leveraged Skyline, Skylink, and the Vantis architecture. That is a statewide network in North Dakota where they're outfitting the whole state of North Dakota with an infrastructure, so users can eventually just log onto the internet and log onto the network and just fly their drones just like you do today with a cell phone, right? You just pick it up and you go. So we got that BVLOS waiver using our avionics, right? A combination of certified and then other avionics that aren't yet certified. We have a test aircraft we used in the BVLOS waiver. And what's interesting is we took a look at there's only a handful of BVLOS waivers in the United States anyway. It's less than 40. It's between 30 and 40. And probably 90% of those BVLOS waivers are using some technology that we've developed at UAvionics, whether it be, an autopilot or a ADS-B receiver or a GPS or whatnot. So it's kind of cool. And then we got a second waiver. We worked with Choctaw Nation in Oklahoma. They have a UAS range there, and we actually got a Choctaw Nation received a BVLOS waiver using our ecosystem as well. So we've got two of those that we've gotten in just this year, and there's only about, like I said, between 30 and 40 of those have been issued in the United States since the program started. So we're sort of proud of that. Go ahead. These are some of the programs. These are the test sites, right? We've got test sites or areas where they're developing UAS technology, right? Some of these are FAA test sites here in the U.S. Some of these are just partners we have that are testing different technologies, especially, how do we integrate drones in an urban environment where there's a lot of traffic, where there's airports, where there's buildings, where there's a lot of GA activity, general aviation. So Choctaw Nation's doing some of that. The Beyond program's doing some of that. NASA's doing a lot of that. Vantis is proving out the network in the way a network would work. And then Northern Plains is a test site. It's not part of Vantis, but it's connected. They're both in North Dakota there. Thales is the provider for Vantis. We are the hardware provider there. We're the hardware and network provider there. We provide both the radios and the ADS-B receivers. And then the FAA, we have a couple of projects in the FAA right now to develop a frequency allocation manager for our Skyline system. That basically is another technology that allows drones to scale. For instance, in the package delivery situation, each drone that goes out to deliver a package would get assigned a frequency for that particular flight. They would go do what they need to do. When they land, they would give up that frequency. It would be allocated to somebody else. So we're developing that for the FAA currently. And then there's interesting ConOps, the linear inspection and delivery ConOps. Malaysia, I was talking Malaysia earlier because they have integrated and mandated what's called a CNPC system in the C-band. So they've kind of taken the lead in Malaysia. And so CNPC is command and control, no payload. So what that does is it says, we're going to have one RF radio link just for your C2 system, just for your telemetry. And then your payload's going to be a second system. So your camera system is not a safety of flight system. It's very important to the UAV, but the C2 system is going to be separated. So that's a system that the defense companies use, the DoD uses. It's a secure way to fly a drone and minimize loss of link or just loss of a drone. We're doing some work with some power utility companies where they're putting in networks. And then down in Latin America, we're supporting some drone delivery operations. UTM and UAS service companies, we're building that ecosystem, not for everything that UTM does, but we're going to give you the command and control. We're going to give you the visualization of other UAS. So that's sort of an important part of that. And then on the OEM side, of course, we support, like I said, we support the type certification process and the BVLOS waiver process. For that, the growing AAM, urban aerial mobility industry, is one that is very interested in a secure network, because eventually they're going to transport, customers, people in autonomous UAS with no pilot is the vision. So you have to have a very secure system, and one that your customers can be confident in. Okay. And this is just a visualization of one of our drones. We have a flight crew, right, with a couple of vans, and then you can see our test drone there. That's an eVTOL, right? So it's a fixed wing with rotors. Pretty common configuration for a lot of operations, BVLOS and delivery. We built that simply for our testing, to test our avionics, to test the performance. And then in North Dakota, we use it to test installation. So if we put an installation in, we'll test it by flying the drone around the installation, see if there's any interference or something like that. So really building a network is sort of complex and takes a lot of dedication, then a lot of testing to make sure it's right, because you don't want to have any holes in the situation. But I think that might be the last slide. Yep. Excellent.
So thank you so much, Joe. So I think we had a huge, amazing audience. So we have lined up with the Q&As, right? First of all, I would like to thank you, Joe. So again, I'm pretty sure it was it might have benefited the all audience, in order to conduct their BVLOS operations, right? So now we would like to again open up a house for the round of Q&As, right? So let me just quickly see where are we on that. So I can see there are a couple of questions coming up for that. So let me start with some of them. So how about a satellite detection network? So that was asked in the chat section, but yeah, this is from start. So Joe.
I'm not 100% sure I understand that question.
So I believe he's asking a more of, since we are talking about RF, like, right, the radio frequencies, how
Yeah.
about how the satellite detection network works? But yeah,
Well,
I think
yeah.
you,
So we're integrating a couple satellite
yeah,
networks. Some of the ones we all know about. We're exploring, Iridium and Starlink and some of
correct,
those. So basically, we would have you'll see a satellite module here from us in the spring. It'll be another SATCOM module on the UAV, and you could use that as a failover. Basically, if you lose one link, it'll fail over to a SATCOM link. Satellite tends to be sort of expensive, so maybe you want to use it sparingly. So there's a way to facilitate so it's a backup, but you're not always using it, so you can save some costs. If that answers the question,
right.
yeah.
Yes, yes. Okay, so moving on to the next one. So there was a question around, do you also have security assurance for EU 2019-945 regulation, CE mark, etc.? So did you get that, Joe?
For EU,
Yeah.
I don't see that question, but yeah, we're working in Europe. Let me see if I can see that question.
So it's in Q&A. You can definitely
Yeah.
more of.
I mean, we have representatives in Europe, and we probably have this C-band system set up in about 6 or 7 countries in Europe right now. So I don't know if I'm actually completely familiar with those regulations. So I'm not going to get a good answer, but you can get a hold of me and I can get back to them.
Right. So I think there was one more question with respect to the radio setup, right? So how do we add in multiple radios for better communications in our aircrafts?
Well, I mean, we have a module for multiple radios. This is one of the LTE modules. So this has got an ISM radio and an LTE radio. So that it could be as small as this. This is like 70 grams. And this manages the link between LTE and ISM, for instance. If you added, you would have to add a second radio, like a C-band radio. This is a full power radio, and then you have 3 radios, and then of course a SATCOM module, and then on the ground you have ground radios. So this is one of our C-band ground radios, right? This gets attached to a pole, maybe 40 or 50 feet in the air, and that is connected to the web. So for instance, in North Dakota, each of our systems has a ADS-B receiver, a ground radio, and then it's web connected. So Skyline, the network manager we talked about, would be web enabled, cloud enabled, which is an advantage. It's hosted, it's web hosted. It records all flight data. So think about this. If you did have an accident where something happened, you had a drone crash, all your flight data is recorded. So that way, if the FAA does an investigation or any other civil aviation authority in another country does an investigation, it's much easier to get to a root cause. You know what happened. You can either blame the network or say, no, it wasn't the network. It was a hardware failure, like a motor or an EUC or something like that. So that's kind of the advantage of that.
Right. So I think there is another question with respect to the use case of the hardware. So I mean, I know like you have already explained this in the slide, but could you please again explain if your technology can be used for remote mapping or wind turbine kind of inspection for this kind of use case?
Yeah, we can. I mean, like I talked to you earlier, we separate the C2 system from the payload system. So currently, our system is just providing the telemetry for the drone. So you would have a second system for video. We're looking at maybe adding another system for video, but right now we're we're building that CNPC system because it's a standard, like I talked about from the RTCA.
Right.
So in theory, you'd have a second system with video, and then those can all be merged. I mean, currently we use Mission Planner, which is an open source mission planning software. That's what we're using. And so you could add your video feed to that. So there's a way to do that. And if we come up with a product in the future, that could also be something. Right now, we're just doing the telemetry.
So, Joe, you talked about the cloud platform that you're going to work on, right? With the whole set of solutions. So, what do you think about, or are there any applications through, or I would say, are there any APIs or any kind of SDKs that will be available for the third-party app integrations for your devices?
Yeah, it'll integrate. I mean, right now we're doing strictly a cloud-based integration, subscription-based integration, but we're working on other options. Right. So yeah, we would have those things too.
Correct.
Yeah, it's a pretty new system. I mean, the masks were sort of approved. They're on version A. So once we got that, we started working with the hardware and then developing that cloud-based application. It's fairly sophisticated now. Just in the last 6 or 7 months, we've added to it, and then we've got customers wanting to use it in different ways. So we're doing redundant systems, duplicate systems, things like that. It also support some of your high altitude applications, like your high altitude pseudo satellite UAVs that fly for 4 or 5 months at a time and beam down satellite or LTE or whatnot. So the use cases are expanding, and it's just, how this industry is. When you think all the use cases, another one pops up. So yeah.
Right. So I think let's take last 2 questions, right? So you talked about C2 frequency, right? C2 frequency band. So there is a question from the customer. So will the C2 frequency band spectrum be available for long distance UAV? And are there any altitude constraints?
Yeah, I mean, they are made for long distance, but the C band is a line of sight radio, so you have distance issues because of mountains or even the curvature of the earth. And the curvature of the earth actually comes in at about, 15, 20 kilometers. So that's why you would have multiple ground radios in a linear inspection type application to facilitate that. I mean, we had to take in Montana, we flew the ground radio in a Cessna at about 10,000 feet. So we just test the distance of the radio, and we got about 150 kilometers before we kind of ran out of room. But so they're very long distance. So like when I talk about the high altitude applications where you have perfect line of sight, that's a really good application without any kind of a repeater. If you need longer distances, then you're going to have to do multiple radios and let it roam like I described on Skyline from one to another.
Yes. So I would say the last question. So could you also please share your thoughts on the OpenDIV approach, where each company contributes to the different layer of drone autonomy stacks, right? What are its benefits, and how can it help us grow the industry?
I mean, there's certain things we don't do. Autonomy is one, and so we don't do uncooperative right now. So that's another technology, but we don't really do autonomy. We support autonomy, right? We support it, right. but we don't do autonomy. We detect aircraft, but we don't have the software, the algorithm to do the detect and avoid. We don't have a flight computer that does the detect and avoid. So that the avoid maneuvers anyway. We detect, but we don't do that. So there's certain things that we just don't do as a company. We definitely want to partner with folks with things like comm systems for payload and integrating with different types of payloads. And then we partner all the time. So if we have a good ConOps concept of operation or use case, we're pretty proactive of wanting to partner with folks if
Right,
it's an
right,
important use case. So yeah, that's an exciting place we'd like to partner and help people move the industry.
right. So with that, I will be closing the event for now. But yeah, thank you so much, Joe. I think
Thank you,
I
Vinyet.
personally learned a lot more in more terms of while talking to customers, while talking to end users, how can I help them with the BVLOS approvals and all, right? So again, I probably love to chat with you anytime again, but I believe it's the same a feeling for the like the audience, right? So I mean, I would like to close, but would you like to share any closing thoughts for this event, for this session?
No, Vignac, I appreciate you guys reached out to us.
Hmm.
This is really a good opportunity for us. There's a lot of activity outside of the United States, we're
Yes.
finding out. And
Right.
maybe in some cases, more activity, especially in commercial operations. So it's good to connect with people outside the United States as well. So much appreciated.
Right. So, okay, thank you so much, Joe. Thank you, audience, right? Thank you all for joining us today. Hope like you have a great time at NetGen. So let us know how you found the sessions in the comments in the chat. So again, coming up next, there are networking sessions and booths. So guys, please do visit that. Okay. Thank you, Joe, for
Thank you,
joining us
Vignac.
today.
Thank you, sir.
Have a good day.